This video is brought to you by mywayteaching.com.
Next topic is Planck quantum theory. Okay, next topic is Planck's quantum theory. So according to Planck's constant theory, substance radiate or absorb energy discontinuously in the form of energy packets. He given the energy, okay, whatever that radiate substances, they radiate or absorb, or they absorb energy discontinuously in the form of energy packets. Okay, so the smallest packet of energy is called quantum. What do you mean by quantum? Okay, so the smallest packet of energy is called quantum. In case of light, the quantum is known as photon. Okay, so what do you mean by photon and quantum? The smallest packet of energy is called quantum, and in the case of light, the quantum is known as photon. The energy of a quantum is directly proportional to the frequency of radiation. Okay, so energy of quantum, see here, energy is directly proportional to the frequency of radiation. So this is E is directly proportional to V. So where that only, so E is equal to Hn, where N is the frequency of radiation. Like you can write E is equal to Hv, or you can just write E is equal to Hn. So how the frequency of radiation, H is a Planck's constant having the value 6.626 into 10 raised to minus 34 joule second. Okay, so a body can be radiate or absorb energy in whole number multiples of quantum Hn, Hnv, H 2hv, 3hv, nhv, where n is the positive integer. Okay, so I think you got it. What do you mean by, where h is a Planck's constant, you should remember the Planck's constant value 6.626 into 10 raised to minus 34 joule second. Okay, and this is the wavelength intensity relationship. So in this wavelength intensity relationship, so this is the intensity versus wavelength. Okay, so see, this is the intensity and this is the wavelength. Okay, so as shown in this figure, intensity versus frequency curve, okay, of the black of from a black body depends only on its temperature at a given temperature. So it depends upon only on its temperature. It is a temperature, okay, which depends upon temperature, which depends upon the temperature. So at a given temperature, intensity of radiation emitted increases with increases of wavelength. Okay, so which increases in increases of wavelength. When the wavelength increases, intensity of the radiation emission is also increases and reaches its maximum value. Okay, so reaches its maximum value at a given wavelength, and then again it starts decreasing with further decrease of wavelength. When again it starts decreasing like this, when the wavelength decreases. So at wavelength, when wavelength increases, it reaches the peak value like this. Okay, so again it started decreasing. So this is wavelength intensity relationship. Next is, you may have the question like, what do you mean by black body? What do you mean by black body radiation? Okay, so what is black body? The ideal body which emits and absorbs radiations of all frequencies is called a black body. Okay, so I will write down the definition for this. The ideal body, the ideal body uh, which emits and absorbs radiations of all frequencies, which emits and absorbs all frequencies, that is called black body. Okay, and what do you mean by black body radiation? The radiation which is emitted by the black body, that is called black body radiation. I think you are familiar with the what do you mean by quantum, right? So Planck gave the name quantum to the smallest quantity of energy that can be emitted or observed in the form of electromagnetic radiation, that is called quantum. Planck gave the number smallest quantity of energy. So this is the smallest quantity of energy, that is smallest quantity of energy. So this is called quantum. The energy of a quantum of radiation proportional to its frequency is equal to hv, where h is Planck's constant, and its value is 6.626 into 10 raised to minus 34 joules. Okay, and the next topic is photoelectric effect. Okay, so what is photoelectric effect? In 1887, scientist Hertz performed a very interesting experiment in which electrons were ejected when certain metals were exposed to a beam of light. Okay, so when the certain this is a metal surface. Okay, but when the certain metals are exposed to the uh, see, when certain metal, this is a metal surface exposed to a beam of light, as shown in this figure, the phenomenon is called photoelectric effect, where the electrons were ejected when certain metals are exposing. So this is the metal surface, consider. So where light is incident, see here, where the light is incident on it, some of the electrons are ejected from this metal. So this is known as photoelectric effect. So they will ask, what do you mean by photoelectric effect? So that by just writing this figure and explaining it, and you will answer the what do you mean by photoelectric effect. So as in the experiment, just now consider the what are the experimental observation in photoelectric effect. Okay, experimental observation: ejection of electrons takes place from the surface of metal when light of suitable frequency fall on it. Just consider this as a metal surface. When light is incident on it, so that the electrons are ejected from that metal surface. Okay, then minimum frequency required for ejection of electron is called threshold frequency. So it is not emitting all the electrons from the metal surface. When there is a suitable frequency is incident on it, uh, below that threshold no electrons will be emitted from that. So above that threshold frequency it will emit the electrons, so that is known as threshold frequency. Next, energy of the ejected electron is proportional to the frequency of radiation. Okay, this is the third one. Energy, it is directly proportional to frequency of radiation. Number of electrons ejected per second depends on intensity of radiation. So hv minus h naught mi is equal to 1 by 2 me into v square. Okay, so this is number of electrons ejected per second depends on the intensity of radiation. Okay, so this is about photoelectric effect. So just you have to explain, if they are asking about photoelectric effect, write down this figure. Okay, so that and then what are the experimental observations? So just write down the 5 points, so that when so you can easily explain about photoelectric effect. And the next topic is dual behavior of electromagnetic radiation. So what is the dual behavior of electromagnetic radiation? So I have just I have already explained about dual behavior. What is dual behavior? Depending on the experiment, we find that light behaves either as a wave or as a particle, so that is known as dual behavior. Whenever radiation interacts with matter, it displays a particle like properties in contrast to the wave like properties. It is interacting with matter, so when it shows particle like properties, okay, that time it will show wave like properties when it is interact with matter. So this is about the dual behavior. Dual behavior means the particle and wave like properties it will be executing, so that is a dual behavior of the matter. So light has a dual behavior. Okay, next is a problem. Okay, can we solve this problem? Okay, the first one is calculate the energy of 1 mole of photon radiation whose frequency is 5 into 10 raised to 14 hertz. So in this we know the formula of E is equal to hv. Okay, they are they are asking to find out the energy. That's why we have written. We know H is equal to Planck's constant 6.626 into 10 raised to minus 34 joule second, where then they have given the value of V. What given value is? V is equal to 5 into 10 raised to 14 hertz. Okay, so 10 raised to 14 hertz. Okay, in that you just applying that, they have asking H in a substitute H value 6.626 into 10 raised to minus 34. Okay, uh, joule second, when it is multiplied with V means 5 into 10 raised to 14 per second. Okay, so this cancel, then finally you're just multiplying after that energy, what you are getting 3.313 into 10 raised to minus 19 joule. Okay, so this is the energy. They are asking for you to find out the 1 mole. So energy 1 mole, so 1 mole, 1 mole, so just multiply this into minus 19 joule. Okay, where which is multiplied with 6.022 into 10 raised to 23 per mole. Okay, so after that you are getting the answer as 199.51 kilojoule per mole. So you know the formula. They are asking you to find out the energy. So U is equal to HV. You know H and the given value is V. Substituting these values and multiplying, you will get this answer. They are asking to find out 1 mole of photon of radiation. Calculate the energy of 1 mole of photon. So that multiplying this answer with the, the value for 1 mole is 6.022 into 10 raised to 23 per mole. So you multiplying, you are getting this answer. Okay. The next topic is, again there is a one problem. So consider the problem. A 100-watt bulb emits monochromic light of wavelength 400 nanometer. Okay, they have given wavelength. Calculate the number of photons emitted per second by the bulb. 100-watt bulb. So they have given the power of the bulb is equal to 100 watt. So this can be written as 100 joule per second. Okay, next, energy of the photon. So calculate the number of photons emitted by the bulb. E is equal to hv. Okay, where hv, then v is equal to c by lambda, where v is equal to c divided by lambda, hc by lambda. So substituting value, E is equal to HV, where H and then V is equal to C by lambda. H, Planck's constant 6.626 into 10 raised to minus 34 joule second. So into 3 into 10 raised to 8 into meter per second for the velocity of the light value. The wavelength 400 nanometer, they have given 400 into 10 raised to minus 9 meter. So cancel this cancel. So and this multiplying this and dividing this, how much you are getting? 4.969 into 10 raised to minus 19 joule. Okay, so number of photons, they are asking number of photons emitted is equal to 100 bulb value, watt, and power value is 100 joule per second. Watt divided by the given emitted answer 4.969 into 10 raised to 19 minus 19 joule. So for this you are getting answer for 2.012 into 10 raised to 20 per second. So this is the answer, number of photons emitted. Okay, and the next one is, again there is a one problem.